Good morning, good afternoon, everyone, based on the time zone. As you can see in my slide, the title of my talk is About, and the full form is About as coined by me, that is analytics with big data. So now, just before my presentation, all of you heard about prompt engineering, and all of us, we know the LLM and all generally deals with big data problem. And here I will be talking about a bit theoretical side. So analytics of big data, what are the opportunities and what are the challenges. However, if we integrate the opportunity and the threats, then we can do well. Okay. Okay. So now already we know that data science, data analytics, and machine learning, it is happening now, and most of the research organization, industry, academia, so everyone is trying to integrate their research with data science. So why suddenly data science? Was it completely new? No, it's not completely new. It was there earlier. However, due to high computational power, we are getting new opportunities. And as per McKinsey, so data science is like it's the #1 catalyst for our economic growth. And after the inception of LLM and ChatGPT, the data science world has completely changed. And most of the big companies, they have started integrate ChatGPT and LLM or prompt engineering in their work. And as a result, the growth and profit is really high. Okay. Now, if we see in the history, so now earlier we could keep only few songs in this type of disk. And however, if we would like to buy a device to store all the music, we can buy it in $600. So now we can understand that data storage that is really cheap. And then if we take the message of Facebook, so there are 30 billion pieces of content is shared every month. And then with the invention of cloud computing also, this type of big data computation, now it is readily available in the remotest places of the world. And now what is cloud computing? So cloud computing, we can say it's like a computing anywhere and anytime. So based on our own convenience and based on our own location, so rather than going, excuse me, rather than going to a particular laboratory or let's say booking a particular slot for computing, in cloud computing, we can do it anytime and anywhere. And it is also known as on-demand computing. Based on that demand, we can access cloud computing. Okay. Now, what make big data valuable? So first is, if we have big data, we can get better and better models. And as a result, the precision is better. So that is why if we have more data, we can come up with better model, and as a result, we will get high precision. So suppose if we take, let's say, for any of the e-commerce industry, now based on the big data analytics, we can suggest some particular personalized product for a customer, and as a result, we can increase the customer satisfaction. Then I think all of us, we have already noticed that in Amazon and Netflix, there is recommendation, and the recommendation is based on the correlated product. Okay, and even I think all of us, we have also seen in the mobile advertisement also. So based on our search history, generally we see the ads. So as a result, the customer, rather than viewing or rather than getting the unnecessary ad, so whatever, let's say I am interested to book a flight after 3 days, and then based on my search history, then I generally get messages what are the different kind of discount. But I don't get what is the discount in the mobile phone, because it is taking the information from my search history. Okay, so now big data generated by machines, and now big data generated by machines, and it is everywhere. Let us take a case of Boeing aeroplane. And here, this kind of planes, there are many sensors integrated it in, and as a result, lots of data are getting generated. And here, generally in each flight, each hour, half of the terabyte of data is getting generated. And as a result, all the maintenance, predictive maintenance, then scheduling of aircraft, delay of aircraft, so everything can be analyzed perfectly. Okay, so now generally the data generated by machine, this is the largest source of big data. So all of us, we use this kind of GPS in our cars. So these generate lots of data. Then this kind of video system or CCTV, they generate lots of data. Then there are recordings. So there are lots of sources which gives us data, and now getting data is really cheap. And as a result, the analytics of big data is really easy. Okay, now what makes the smart device more smarter? So first is it has the ability to connect with other devices or other networks. Then it has the capability to collect and analyze the data automatically, and also it provides the environmental context. Okay, and the Internet of Things. So in the era of Internet of Things, everything that we use are connected with internet, and everything we are able to operate through our mobile phone. So we can say that these IoT or Internet of Things, these basically connect the whole world. Okay, next is the big data generated by machines, why it is useful. So this I already said that aeroplane, there are lots of data is getting generated. Now, the thing is, suppose turbulence. Now, if the pilot can predict the turbulence, necessary actions can be taken. Then even suppose there is some change in temperature or pressure, or there is some other problems, then we can predict what are the malfunctions, and then based on the malfunctions, we can take decision before the accident occurs. And another thing is this type of real-time problem detection, we are able to do 40,000 above. Okay. Next is big data generated by people. We the people, or let's say even we the researchers, we also generate a lots of data, and most of the data are unstructured data. So here, when we check our email, we use Twitter, internet searches, then Google Docs, taking picture, YouTube, Instagram, Facebook. For everything, we are generating lots of data. And most of these data, they are text heavy and they are unstructured. And the daily data generated in Facebook, that is greater than all US academic libraries. So now we can understand what is the volume of everyday Facebook data. Okay. And other than this, even eBay, Google, Twitter, Spotify, they also really generate lots of data. Okay. So now this kind of data generated by people, how it is getting used. So now there are many challenges. One is how to store the data. Is the data authentic? Even the last speaker told about the prompt engineering and the hallucination. So now these challenges, even though there are many challenges, there are many opportunities. Why there are many opportunities? Suppose, let us take a very small example. Suppose one of us, we would like to buy an apartment, let's say in Melbourne. Now, to buy an apartment, so what we can do, we can ask, let's say 10 different people who already own an apartment in Melbourne, what is the size of their house and what is the price of their house. Just one input, one output. And then we can fit a very simple model. And then we can say that, okay, based on, let's say this linear model, this could be the price, but it may not be 100% accurate. On the other hand, if we pose it as a big data problem, so rather than only taking the size and the price, we can take all other aspects like how many bedrooms, how far it is from the hospital, how far it is from, let's say, good schools, big shopping malls. And then many people, rather than giving the data in a structure form, so they may just give the picture, or someone may just give the information verbally. So now we can integrate all of these and consider it as a big data problem. So here, what are the challenges? Challenges are that it's a hybrid data science problem in which, in addition to structured data, we also have unstructured data. Now, and what are the opportunity? The opportunity is that in comparison with a simple model, due to these large volume of data, or we can say large volume of hybrid data, it's a good opportunity for us that we can find, or we can do a better judgment or better prediction. So basically, if we can integrate the challenge and opportunity, the result is that we can do better prediction. Okay. And now for big data analytics, there we have Hadoop ecosystem, even we have Spark ecosystem, even as most of the data science or machine learning people use Python, even Spark has been integrated with Python, and it's PySpark, which is easy like Python. Okay, here let me give two example. So for the UPS, so for the UPS, they have to ship 16 million delivery every day. So it's really huge. And then there are 40 million tracking requests. And as a result, they estimate to have a 16 petabyte of data about its operation. Okay. So now, as UPS is able to do big data analytics, so they can actually do very good supply chain analytics. And as a result, they are able to reduce the cost for each driver's route bus just in 1 mile. So there is a very good saving. And now if we integrate with the whole UPS supply chain, it's really a saving. And generally in 1 mile, the saving, sorry, not 1 mile. So if we reduce every driver's route just by 1 mile, then there is a saving of $50 million per month. So basically what they do, they have large operational data and they have supply chain optimization algorithm. And as a result, they do the route optimization. And as a result, they can have huge saving. Okay. Now, what are the characteristics of big data? Or because now if it is big data, so is there a particular number? So is there like number of column, number of rows, number of training data for which I will say big data? So now, generally there are V's in which we say that it's a big data. First is the volume of the data. So volume of the data should be much high. Then velocity. So the streaming of data. So when it's like natural language processing or video data, so it's a continuous streaming of data. So the volume should be high. The streaming of the data should be continuous and it should be high. Then there should be a variety of data. As I have given the example of housing price. So here variety of data, we mean, let's say there are data which are tabular or structured data type. Then there are also unstructured data type, which may be, let's say, either image data, video data, or voice data. And another is veracity of data or the uncertainty of data. Okay. So now, basically, what we want, so from all these things, it should generate value. Okay. So now these are the characteristics: volume, which is basically the size of the data, then the velocity, the speed in which data is coming, the valence, what are the connectedness between diversified data sources, then what is the veracity or uncertainty, or what is the quality of the data. let us say that in prompt engineering, if our prompt is bad, maybe the output will be bad. Then what are the different variety of the data? And all these V, it should generate value. If it is able to generate value, then we say that yes, we are successful. On the other hand, if our prediction is bad, or if there is no cost saving, then we can conclude that our big data analytics, this is not a successful one because it could not help us in saving. Okay. Now, to do big data analytics, so there are certain processes which are basically acquire, prepare, analyze, report, and act. I will explain each of these. So now, what we have to do, we have to first build the model, then exploit the data, and then maybe scale the data if they are different scale, and then we have to report, and then based on the saving, we have to act. Okay, so first is we have to ask the right question. Now, if we have a very good business understanding, then we can do a proper analysis. So that's why the business analyst, that is one of the necessary things in the process of big data, because if we just treat the problem as a machine learning or as a mathematical problem, so we may miss some aspects because we don't know what is the contribution of different input data. Okay, then we have to assess different situation, like what are the risk, what are the benefits, what are the regularization, then what are the resource requirement or what are the constraints that are coming into picture. And then we have to define what are the objective of our analysis and what is the criteria of our analysis. Okay. And after that comes the data science process. So here, as I already mentioned, first we have to acquire data or we have to get the data. So here, the process involves the identification of the data set. And after the identification of the data set, we have to retrieve the data and then we have to query about the data. Then step two is basically to prepare the data. After we get the data, we have to explore the data. Let's say we use either feature engineering or exploratory data analysis. And then before put it into data analytics or big data analytics model, we do pre-processing of the data. So here in the exploratory data analysis, we try to understand what is the nature of the data or how the data is distributed, and we do preliminary analysis. And then in the pre-processing of the data, we clean the data if there is anything missing or if there is any noise, and then we integrate all different data. And thereafter, we generally analyze the data by different analytical techniques, and then we build the model. And then after building the model, we get the result, and then we generally communicate the result with the team members or with our managers. And then we try to apply the result and then check it in the new environment to understand that how it is performed in the new data set. And basically, all this is a iterative process. Okay, so here there is one very important thing which basically I said threat and challenges are also there. So now there are many times there are data quality issues. So to deal with data quality issues, what we do, we generally remove the data which has missing value, and then we generally merge the duplicate records, and we generally mark the outliers. But here, when we remove the outliers, there are two problems. One is sometimes it is possible that outliers are bad. So if outliers are bad and if we remove the outliers, that is okay because we are just removing the data which is not required. On the other hand, it is also possible that the outliers, they are not bad. They are just some kind of rare events. So now, if we remove the rare events, so it means that we are missing some aspects. So that's why to deal with this, we should have some domain expert in our team. Because if we only treat it with a data science problem, it's possible that, as I said, we may miss some aspects which is important. Okay. And now, after getting the result, so rather than just present the result only in numbers, if we can make some kind of visualization, this is easy for the person to make decision, because rather than only seeing the data or seeing the numbers and making some decision, if we can make the visualization, it's always better to make decisions. Okay. So now after getting the result, we have to basically take action, and we have to determine what are the next step. So in the evaluation part, we have to see if the results are they favorable or are they meeting our criteria. If not, we have to revisit. So in the revisit, what we do, so either we change the model, or maybe we try to either get some more data from different sources, or maybe from the same distribution. And then we try to understand what are the further opportunities, and then we take real-time action. Okay, so that is all about my presentation.